Hello everyone. In this tutorial, I'm going to talk about the jitter or stutter issue caused when moving the camera around in first-person view and how to fix it. By jitter issue, I mean something like this, where when you rotate the camera, everything else seems to jitter. If your game is facing jitter issues with camera, then this video will give one of the solutions. I have also uploaded this tutorial project to my GitHub. The GitHub link is in the description below. Also, I have divided the video in chapters, so you can skip to where you want to go if you want to. When I first faced this issue, I did a lot of research to figure out how to fix the problem. But unfortunately, it did not work, so I figured I probably had a unique problem. So in the description below, I'm linking all the resources that I tried to fix this issue, because my solution may not fix your issue and it could be any one of the solution in the links. Okay, so let's get started. For this tutorial, I'm using Unity 2020.3.3f1. So create a new project and call it Tutorial FPS Rotation. I already made the project, so that's why it's saying path already exists. But in your case, you name the project and then press create. It is always best to organize, so after the project opens, create a folder and name it similar to the project name, which is Tutorial FPS Rotation. Let's go to create, folder, Tutorial FPS Rotation. Inside the folder, create 3 new folders and name them Scenes, Materials, and Scripts. Now go inside the scene folder and create a new scene and name it Test1. Excellent. And also in the game window, make sure to enable stats. This will be useful later on. And also open the new scene, and it should say Test1 here. Alright, so now let's make the basic model for our game. First, create a new game object and name it root. Make sure it is at 0, 0 position. Inside root, create a new game object called environment. Now inside environment, create a basic 3D plane object and scale it to 20 in all directions. Brilliant. Let's give it a material so that we can differentiate from other models. Let's create a material in the material folder and name the material to ground. Give it a green color and make the smoothness to 0. Now drag and drop the material into the ground. Awesome. Okay, so now we need to create a center object so that we can observe if the camera rotation is rotating smoothly. Create an empty game object inside the environment and call it cubes. Then inside cubes, create a Unity3D cube model and move it to 0.5 in y-axis. The reason for doing it this way is because now we have artificially moved the pivot of the cube a bit up. So now when we change the size of the cube, the bottom part of the cube will remain where it is. Alright, now select the cube game object and change the scale of the object to 5, 10, and 5. Let's give this cube a material. Go to the material folder and create a new material, call it cube. Give it a brown-like color and reduce its smoothness to 0. Cool. Now let's create the player model. Inside root, create an empty object and call it player. Inside player, create 2 new game objects and call them camera holder and model. Inside the model, create a 3D capsule model. Move the capsule by 1 in y-axis and you can remove the collider. Now drag the main camera into the camera holder game object and reset all the transform values of the camera. You can move the player a bit outside so that you can see it. Now select the camera holder and move it by 2 in the y-axis because that is where the head should be for this model. Nice. Now we are done with creating the models. Let's make the scripts now. Create the first script and call it player in the script folder. Create the second script and call it PlayerMove. Create the third script and call it PlayerRotate. It is good to separate the functionality because then it becomes easier to debug if anything goes wrong. Plus the code looks good. Open up the PlayerMove script first and create a stub method called move. Then open up the PlayerRotation script and create another stub method called rotate. And save them. Now open the player script. Let's give some required components for this class. This means that when you add player component to a game object, then the required component will automatically be added, reducing any chance of errors. You don't need to give required components for this class to work, but it is a good practice to do so that you don't run into errors because you forgot to add other components that this class needs. Awesome. Now right above the class name, add the required components for this class. For this player component, we will need character controller, PlayerMove, and PlayerRotate. Now let's create the variables we will need. First is the PlayerMove and call it _move. Next is the PlayerRotate and call it _rotate. Since we added required components, we are sure that this player class will have a PlayerMove and a PlayerRotate component. So let's store them in the awake method like so. Also, let's make sure that the mouse is in the center when the game starts so that it is easier to rotate the player camera. Awesome. Now in the update method, we just call the stub methods that we created like so. Excellent. Now save everything. Now let's open the PlayerMove script. This script will be only responsible for moving the player. The first thing we will need is the movement speed. So let's create a float variable and name it speed. It is good to keep things private that does not require access by any other class. Giving the serialized field tag in front of any private or protected variables will expose the variables in the inspector. Okay, now create a character controller and name it _player. This character controller will be responsible for moving the player character. Then create a vector3 variable called _moveDIR. This variable will be used for calculating in which direction the player should go. In the awake method, store the character controller like this. If your method has only one line of code, then you can write the method code like this, which looks nice and is easier to read. Now in the move method, we need to do the movement calculation and moving the player. So let's store the movement calculation inside _moveDIR. First, get the transform right and multiply it with input.getAxis horizontal. The input.getAxis horizontal is a predefined key binder in Unity, which is the A and D keys and also the left and right arrow keys. So whenever these keys are pressed, a float value is sent back. We are multiplying the key value to the transform.right because this will make sure that the player is moving to sides depending on the player forward direction. So whenever the player rotates, the side movement will be in the correct direction. Then we add the side movement to the forward movement like so. The input.getAxis vertical is a predefined key binder in Unity, which is the W and S keys and up and down arrow keys. This too sends back a float value when the keys are pressed, and that float value is used to move the player forward and backward. Now we multiply it with the speed that we provided. Finally, we move the player by multiplying the entire move direction with time.deltaTime. Now save everything. Excellent. In the editor, select the player model. At the player script, you can see all the needed scripts have been added as well. In the character controller center point, give 1 in the y-axis. This will bring up the character controller to the correct position. Then in the PlayerMove component, give the speed value to 10. Then run the game. The player is moving smoothly using the WASD keys and everything seems fine. Awesome. Alright, so now let's rotate the player. Open the PlayerRotate script. Now let's add some variables. First, we will need a transform called _camera_holder, which will be used for rotating the camera holder. Then a float _speed, which will be the rotation speed. We will need another float variable called _rotation_limit, which will be used for limiting the vertical rotation. Then we will need another float variable called VertRot, and this will be a protected variable. This variable is protected because later the child of this class will need to use VertRot. The VertRot will be used to keep track of the vertical rotation, which needs to be limited. Okay, so now let's write some code in the rotate method. So let's update the VertRot by subtracting it from a method called getVerticalValue. Let's create the method and make it protected so its child classes can use it as well. We first get the input.getAxis mouse y float value. This is the float value returned when moving the mouse up and down. We multiply the mouse value to the speed and time.deltaTime. The reason we are subtracting the VertRot value is because the mouse up and down float value is inverted. So to rotate the camera correctly, we need to subtract the value. Now we need to make sure that the VertRot value is within the rotation limit. To do this, we need to use ternary conditional operator. So when VertRot is less than equal to minus rotation limit, then make it minus rotation limit. If not, then VertRot greater than equal to rotation limit, then make it rotation limit. If not, keep it as VertRot. Basically, this means is if the condition is true, then use the first value, else use the second value. You can also give another ternary conditional operator instead of values. Doing it in this way makes sure that we can do the entire check within one line instead of giving a bunch of if-else conditions. After checking the VertRot value, we need to rotate the player model vertically and horizontally. So let's create a protected virtual method called rotateVertical. We made this method protected virtual because we want to allow the child classes to update this method if needed. For vertical rotation, we shall rotate the camera holder only and we will rotate it like this. We will call this method here. Next, we will create protected float getHorizontalValue. The input.getAxis mouse x returns a float value, which is the mouse sideways movement. Finally, we need another method that will rotate horizontally. So let's create another protected virtual method called rotateHorizontal, and we shall rotate the player game object, which is the transform, like this. We shall call this method here and save everything. Awesome. Now back in the editor, we need to fill up the variables. So let's place the camera holder here and then give the speed value to 200 and rotation limit to 90. Cool. Now save your project. Now let's test the game. Depending on your hardware, when you run the game in editor, some of you will see a smooth rotation and some of you will not. Also, take note on the FPS of the editor, which in my case is around 400 to 600 FPS. Alright, now let's build the game and test it there. To build the game is easy, just go to File and then Build Settings, or press Ctrl-Shift-B for shortcut. Then drag and drop the test1 scene in the Scenes in Build window and then click the Build button. I am going to create Builds folder, and inside it we'll create another folder called Test1 and build the game there. Once you are done, then start the build game. Now circle around the center object and you will notice the game is stuttering a lot. I am using NVIDIA Shadowplay to see the game's FPS. You can use any software that shows the game's FPS. If you look at the top right corner, then you can see the FPS of the game is around 60 FPS. That is not a lot compared to the editor's FPS, which was around 500 at most. In my research, this drop in FPS is what causing this jitter issue. You may be asking, then why did the FPS drop so much? It is because of VSync. In Unity, VSync is enabled by default and for good reason. The VSync makes sure that the frame rate of your game is same as the refresh rate of your monitor. This makes sure that there are no screen tearing, especially when looking around too quickly. So in my case, the refresh rate of my monitor is 60 Hz or 60 FPS, and that is why the game's frame rate dropped to 60 FPS. If your monitor has different refresh rate than mine, then FPS will drop to that refresh rate. You could solve this by just disabling the VSync and the game will run smoothly, but as I said this before, this will create another problem, which is the screen tearing effect. I will not recommend to do that, especially if your game is a fast-paced game. To disable the VSync, simply go to the Edit, then Project Setting. Then in Quality, under VSync Count, change every V blank to Don't Sync. This will disable the VSync. Again, this is not recommended and this is not my solution. I just wanted to share there was another way if everything else fails. Now to my solution for fixing the jittering issue. Turn on the VSync if you have turned it off by changing the VSync count to every V blank. Close the project settings. In Scripts folder, create another script called PlayerRotateSmooth. Open this script. The first thing we are going to do is to make this class a child of PlayerRotate class. By extending the PlayerRotate class, we can keep the rotation logic as is, but will only change logic where we have given access to, which were the protected variables and protected virtual methods. Alright, first let's give a header so that in the inspector window, we will know which component we are making changes to. Header is not needed for this script to work, it is just for helping in reading the inspector. So give header and name it PlayerRotateSmooth properties. Then in the PlayerRotate class, give a header saying PlayerRotate properties. You can name it anything you want. We are going to use smooth damp angle to rotate toward targets. So let's see the docs what the smooth damp angle does. Description: gradually changes an angle given in degrees towards a desired goal angle over time. The value is smoothed by some spring damper like function. The function can be used to smooth any kind of value, positions, colors, scalars. The most common use is for smoothing a follow camera. So let's see what it takes. It takes a current float, which is the current position, a target, which is the position we are trying to reach, It takes in a reference float called current velocity, which is the current velocity. This value is modified by the function every time you call it. So basically it does some calculations that may be needed for something else, but we will not use this value. Then it is the smooth time, which is approximately the time it will take to reach the target. A smaller value will reach the target faster. Basically, it is saying the time that is needed to reach the target. These are the 4 parameters that we need to fix this jitter issue. The other 2 is not needed. Now back in the PlayerRotateSmooth script, create serialized field float called _smoothTime and a transform called _HoriRotateHelper. Then create private float called _vertOld, _vertAngularVelocity and _HoriAngularVelocity. Our targets are vertrot and _HoriRotateHelper. In the start method, set the local rotation of the _HoriRotateHelper to the transform local rotation so that they are in sync when the game starts. Now we shall only override the methods in the parent class. Override the rotate method. Store the pre-calculated value of vertrot in vertOld. Once the base.rotate method is called, the vertrot in the parent class is given a new value after calculations are done in the parent's class. Now let's override the rotate horizontal method. Remove the base.rotateHorizontal method because in this case we don't want any calculations done from the parent class. Now first rotate the HoriRotateHelper like this. Then rotate the transform local rotation in the y-axis only by transform.localRotation equals quaternion.Euler, then give 0. Then mathf.smoothDampAngle. We shall rotate from transform.localEulerAngles.y to HoriRotateHelper.localEulerAngles.y. Then we give the angular velocity reference, which is in this case HoriAngularVelocity. Lastly, we will rotate it in smooth time, and then another 0. As you can see, I am using the HoriRotateHelper's local Euler angle y-axis to rotate the transform. Maybe someone with higher understanding of quaternion calculation can do this rotation without the need for HoriRotateHelper, but in my case, I need it to store the target rotation value. Next, we are going to override the rotate vertical method. Before calling the parent's rotate vertical method, we will need to smooth the vertrot value. This is easily done. Vertrot equals to mathf.smoothDampAngle. Our current value is vertOld and target value is vertrot. The angular velocity reference for this one is vertAngularVelocity and the time to reach the target is smooth time. And next, the parent's vertical rotation is called. Excellent. Save everything. Now we need to make some small changes in the player class. Open the player class. Add PlayerRotate_RotateSmooth and PlayerRotate_currentRotate. In the awake method, use getComponents to get the PlayerRotate components. GetComponents helps to get similar components from a game object like an array. The top one being in the array position 0 and the next being in array position 1 and so forth. So for the rotate, it is in array position 0. For rotate smooth, it is in array position 1. For now, we are going to make the current rotate to rotate smooth. Since the PlayerRotateSmooth is a child of PlayerRotate, the rotate smooth can be PlayerRotateSmooth, and when the rotate method is called, it will use the PlayerRotateSmooth's rotate method. Replace the rotate in update with current rotate. Excellent. Now save everything. Now let's go back to the editor, create a game object inside the root and call it HoriRotateHelper. Select the player model, add the PlayerRotateSmooth to the player, move it one step up for easy readability, Make sure it is not above PlayerRotate, otherwise PlayerRotateSmooth array index will be 0. Now fill up the variables. Place the camera holder here. Give speed about 200. Rotation limit is 90. Give the smooth time to 0.02. And drag the PlayerRotate helper game object to the PlayerRotate helper. Cool. Now save everything. Now build the game and store it in another folder called test2. Run the game and voila! The first person rotation is rotating smoothly without any jitter or stutter at 60 FPS. This does feel good to the eyes. But wait, there is one problem. Let's go back to the editor and run the game there. You will notice that the rotation in the editor is very slow, and increasing the speed does not help that much. But the player rotation script was working fine in the editor, so we can't just keep changing the player script to use the player rotate while in editor and player rotate smooth while in the build. That will lead to mistakes being made. So in this case, what we can do is use Unity's platform-dependent compilation. We can use that to tell Unity that when the game runs in the editor, the player rotate should be used, and when it is running in build, then the player rotate smooth should be used. Now, open the player script. Remember that we gave a current rotate variable? Well, that will be in use now. In the awake method, we are going to tell Unity when to use what type of rotation. To do that, we write # if Unity_editor. This means if the running platform is Unity editor, then we say current rotate equals to rotate. Then else we say current rotate equals to rotate smooth. Then lastly, end if. So this part basically means if the running platform is Unity editor, then use rotate, and for everything else use rotate smooth. Save everything. Now if we run the game in editor, we can see it is rotating smoothly. Let's build the game in another folder called test3 and run the game there. And as you can see, it is rotating smoothly here as well. So that is my solution for fixing the jitter or stutter issue with first-person camera rotation. Tell me in the comment section if this worked for you, and please like and subscribe. That will help me a lot. Alright, take care, stay safe, and K out.